In this question, you're asked to find the values of a for which a plus 3 times x square minus ax plus a minus 3 is greater than 0 for all x belongs to R. So this quadratic expression has to be greater than 0 for all x belongs to R. In this question, be careful. You're not asked to solve this inequality. Whenever you're asked to solve the inequality, you will be given all the numbers and you will be asked to solve the inequality. Here, the answer to this inequality is already given. That means this expression is greater than 0 for all x belongs to R. That means the solution of this is all real numbers. If that is so, you're asked to find the values of unknown. So this question is based on the concept that if a quadratic expression is greater than 0, if the quadratic expression is greater than 0 for all x belongs to R, then the condition is the leading coefficient has to be positive and discriminant has to be negative. So this is the condition for a quadratic expression to be greater than 0 for all x belongs to R. So this implies a plus 3 is greater than 0 and discriminant is b square minus 4 times a square minus 9 is less than 0. b square minus 4 into a into c. So a plus 3 is greater than 0 and b square minus 4 times a square minus 9 is less than 0. This implies a has to be greater than minus 3 and a square minus 4a square is minus 3a square. Minus 4 into minus 9 is plus 36 is less than 0. Or 3a square is greater than 36. So a square greater than 12. This implies a is either greater than 2 root 3 or a is less than minus 2 root 3. Right? This is a very standard inequality. A square greater than 12. So either a is greater than root 12, that is 2 root 3 on the positive side, or a is less than minus 2 root 3 on the negative side. So if you plot the solution on the real number line, so you have plus 2 root 3 and minus 2 root 3. So if a is greater than 2 root 3, a square will be greater than 12, and a is less than minus 2 root 3 also. Once you square it, the number will be more than 12. So this is the solution for this side of the solution, and a has to be greater than minus 3. This also has to happen. So where will minus 3 lie if you plot both the solutions on the same real number line? So what is 2 root 3? So 2 root 3 is nothing but root 12. So root 12 will be 3 point something. So this will be plus 3 point something. This is minus 3 point something. The second part of the solution says that a is greater than minus 3. So minus 3 will be somewhere here. So this part of the solution says that a has to be greater than minus 3. So now this has to happen and this has to happen. So I need to take the common solution, not the combined solution but the common solution. So what are the values of real numbers which satisfy both the conditions? So obviously you can see that this part does not satisfy this condition. So the solution is a belongs to 2 root 3 to infinity. So a has to be greater than 2 root 3 such that this has to be greater than 0 for all x belongs to R. Thank you.